Go.
Hello, my name is Jocelyn Hernandez and I will be demonstrating how to solve a system of equation by substitution. The method of solving by substitution works by solving one of the equations. You choose which one for one of the variables and then plug this back into the other equation, substituting for the chosen variable and solving for the other. When I refer to solving a system equation, I want to solve for a numerical value for one variable. In this section, I will describe how to do that using substitution. Example 1. 2x minus 3y equals negative 2 and 4x plus y equals 24. The idea here is to solve one of the equations for one of the variables and plug this into the other equation. It does not matter which equation or which variable you pick. There is no right or wrong choice. The answer will be the same regardless, but some choices may be better than others. For instance, in this case, can you see that it will probably be simple to solve the second equation for y, since there already a y flowing around loose in the middle there? I could solve the first equation for either variable, but I'll get fractions, and solving the second equation for x will also give me a fraction. It wouldn't be wrong to make different choice, but it could probably be more difficult. So I will solve the second equation. 4x plus y equals 24. Now I will subtract negative 4x to both sides, which will give me y equals to negative 4x plus 24. Now we'll plug this in for y in the first equation and solve for x. 2x minus 3 open parentheses minus 4x plus 24 close parentheses equals negative 2, which that will give me 14x equals to 70. Now we'll subtract 14 to both sides and that will give me x equals to 5. Now I can plug this x value back into either equations and solve for y, but since I already have an expression for y equals, it will be simple to just plug into this. Y equals to negative 4, plug in 5 plus 24 equals to negative 20 plus 24, which equals 4. Then the solution is 5 and 4. Warning, if I have substituted my negative 4x plus 24 expression into the same equation as I used to solve for y equals, I would have gotten a true but useless statement. Because 4x plus open parentheses minus 4x plus 24 close parentheses equals 24, which gives me 4x minus 4x plus 24 equals to 24. 4x cancels out and that will give me 24 equals 24. 24 does not equal 24, but who cares? So when using substitution, make sure you substitute into the other equation or you'll just be wasting your time. Example 2. Y equals 36 minus 9x and 3x plus y over 3 equals to 12. The first equation is already solved for y, so I'll substitute that into the second equation. 3x plus open parenthesis 36 minus 9x close parenthesis times 3 equals 12. That will give me 3x plus 12 minus 3x equals to 12, and that will be 12 equals to 12. Well, yes, 12 does not equal to 12, but so what? I did substitute the first equation into the second equation, so this unhelpful result is not because of some screw up on my part. It's just that this was a dependent system looks like when you try to find a solution. Remember that when you're trying to solve a system, you're trying to use the second equation to narrow down the choices of points of the first equation. You're trying to find the one single point that works in both equations. But in a dependent system, the second equation is really just another copy of the first equation, and all the points on the other line will work in the other line. In other words, I get an unhelpful result because the second line equation didn't tell me anything new. This tells me that the system is actually dependent and that the solution is the whole line. Solution is y equals to 36 minus 9x. This is always true, but the way. when you try to solve a system and you get a statement like 12 equals 12 or 0 equals 0, something that's true but unhelpful. I mean, duh, of course 12 equals to 12. Then have a dependent system. We already knew from the previous lesson that this system was dependent, but now you know that the algebra looks like. Keep in mind that your text may format the answers and look something like 36 minus 90 or something similar using some variable, some parameter other than x. But this parameterized form of the solution means the exact same thing as the solution in the line y equals 36 minus 9x. Example 3. 7x plus 2y equals 16 and negative 21x minus 6y equals 24. Neither of these equations is practically easier than the other for solving. I will get fractions no matter which equation and which variable I choose. So I guess I'll take the first equation and also F for y because at least the 2 from 2y will divide even into the 16. Note that this is quite different from the previous example. Warning, a true but useless result like 12 equals 12. It's quite different from a nonsense garbage result like negative 48 equals 24. Just as two identical lines is quite different from two parallel lines. Don't confuse the two as the useless result means a dependent system which has a solution, the whole line. A nonsense result means is an inconsistent system which has no solution of any kind. This is the first equation. 7x plus 2y equals 16. 2y equals negative 7x plus 16 will give me y equals to negative 7 over 2x plus 8. Now we'll plug this into the second equation. Negative 21x minus 6 open parenthesis minus 7 over 2x plus 8 close parenthesis equals to 24. Equals to 24. Negative 21x plus 21x minus 40 equals to 24. That will cancel out the negative 21x, and so I'll get negative 48 equals to 24. I don't think so. In this case, I got a nonsense result. All my math was right, but I got an obvious wrong answer. So what happened? Keep in mind that when solving, you're trying to find where the lines intersect. What if they don't intersect? Then you're going to get some kind of wrong answer when you assume that there is no solution, as I did when I tried to find that solution. We knew from the previous lesson that this system represents two parallel lines, but I tried by substitution to find the intersection point anyway, and I got a garbage result. Since there wasn't any intersection point, my attempt led to utter nonsense. So the solution is no solution, inconsistent system. And this is how you solve a system equation by substitution.